Start.
माझं नाव सान्वी आहे. माझं नाव जान्हवी आहे. एसके सिव्हिल इंजिनिअरिंग सबस्क्राइब करा. मला इंजिनियर बनायचं आहे.
Okay, good. Santosh here, and today I am going to deliver a lecture on water supply engineering and which deals with the filtration. After a long gap, I am delivering this video or lecture on my YouTube channel because of other issues and other works, and I am right now joining to deliver this lecture on filtration to you people. Before starting the lecture, I want to give you a valuable story, want to deliver you a valuable story on filtration, and that story is the triple filter test. You must know that the Socrates is a great philosopher in the Greece, and one day one man went to him and told him that I want to tell you about your friend. Then the Socrates told him that first of all, you should pass my triple filter test. That man got surprised and said that what is that triple filter test? Socrates smiled and told him that my first test is whether you are going to tell me a truth. The first test is regarding the truth. First filter is the truth. That man don't know the exact truth, so he said no. Then Socrates said okay. Then he asked him the second filter test. That second filter test is of goodness. Then that man told Socrates that he don't know how it is good or bad. Then Socrates tested him for the third filter test, and that third filter test is nothing but regarding the usefulness of that issue. But that man told him that might be a useful or may not be a useful. Then Socrates told him that you don't tell such a stories to me which doesn't have any truth, doesn't have any goodness, and doesn't have any usefulness. But such a types of filters we have to use in our private life and social life. Second story about filtration is Mpsc exam is nothing but the filtration, and that is also triple filter test. The first filter is the prelim, the second filter is the mains, and third filter is the interview. So the filtration is very important process, and let us start this lecture. And before starting this lecture, I am requesting the civil engineers and other interested persons and peoples to subscribe my channel to get more and more ideas about civil engineering. And those who have subscribed my channels, I once again say them thank you very much. So let us start the filtration. What is the filtration? It is one of the important operation in water purification process, as previously told you in the stories. Though screening and sedimentation remove a large proportion of suspended matter, but they do not effectively remove the flow particles, color, dissolved minerals, and microorganisms. In filtration, water is passed through a filter medium in order to remove the particulate matter not previously removed by the sedimentation. Means filtration is the process to remove the material which are not removed by the sedimentation. During filtration, the turbidity and colloidal matter of non-settlable type are removed. It precipitates the color, and the chemical characteristics of the waters are changed. The bacterial content of the water is considerably reduced due to presence of an active zoological layer on the top of filtered material. James Simpson established the first filter for Chelsea Water Company in London in 1829. earliest forms were slow sand filter type. Rapid sand filters were introduced in 19th century. Then we are going to discuss the theory of filtration. It is very important and you people must know what is the theory of filtration. When water is filtered through the bed of filter media, usually consisting of clean sand, the following actions takes place. The first action is the mechanical staining, second action is the sedimentation, third action is the biological action, and fourth action is the electrolytic action. So how to remember that? MSB, you know the MS and you know the B. M means mechanical staining, S means sedimentation, B means biological action, and E means electrolytic action. We are going to discuss these processes in short, and you should study these processes in book very elaborately. Mechanical staining, this is the simplest action taking place during the filtration. The suspended particles are usually larger than the pore space or the void of the filter media, and hence they are arrested and removed when water passes through such a filter media. The major removal takes place only in the upper few centimeters of the filter media. These arrested particles form a material and further help in staining the impurities. So mechanical staining is nothing but the removal of the particles which are get arrested into voids. Then second is the sedimentation. In mechanical staining, only those particles which are coarser than the void side are arrested. It is very simple. If the void space is less and particle size is more, such a particles get arrested. But the particles which are smaller than the void space, that finer particles are arrested by sedimentation action. All the colloids are thus removed by this action. Sedimentation is removal of the all colloidal material. Then third one is the biological action. What is the biological action? When the filter is put into commission and the raw water is passed through it, during first few days the upper layer of the sand grains become coated with reddish brown sticky deposit of partly decomposed organic matter together with iron, manganese, aluminum and silica. After some time there exists in the uppermost layer of the sand a film of algae, bacteria and protozoa, etc. Means there is a formation of film on the top particle of filter media and which consisting of algae, bacteria and protozoa. This film is known as a dirty skin which act as an extremely fine meshed staining material. The organic impurities in the water become food to different microorganisms residing in that filter bed. The bacteria not only break down the organic impurities and also they convert them into harmless compounds, but also destroy each other and maintain a balance of life native to the filter. So the biological action means nothing but the formation of film, and this film is useful for decomposition of organic material. Then fourth action is the electrolytic action. Another function of the filter is to remove the particulate matter by electrostatic exchange. The charge of the filter medium neutralizes the charge of the flow, thereby permitting the flow is to be removed or to be removed. During the process of backwashing, the electrostatically neutral material is removed and the charge of filter media is replaced. That is electrolytic action. So you must know that the charge of the filter medium, the charge on that filter medium neutralizes the charge of flow. That is very important. Then we are going to discuss the classification of filters. It is very important chapter or very important part of this chapter. Filters are mainly classified into two classes. First is the slow sand filter and second is the rapid sand filter. Rapid sand filter is again divided into two categories, gravity type and pressure type. The difference between this type of filter always asked in the examination, and it is mainly in head required for filtration, rate of filtration, then composition of the filter media, and method and frequency of cleaning of that filter media. Then we are going to discuss the slow sand filters. Name itself indicates slow filtration. Slow sand filters were earliest type of filters introduced in 1829. So before 19th century they are introduced. Slow sand filters are so called because rate of filtration through them may be 1/20th or less than the rate of filtration through the rapid gravity or pressure filters. Because of low filtration rate, slow sand filters require large area of land and costlier to install. They are very expensive to operate due to laborious method of bed cleaning by surface scraping. Due to this, new construction of slow sand filters is largely confined to the additions to the existing of slow sand filter plants. Slow sand filters do not normally utilize coagulation to prepare the water for filtration. The only pre-treatment even used on the water to be filtered in a slow sand filter is primarily settling in a sedimentation tank without any coagulation. So you must know this difference. Due to this, slow sand filters are not suitable for dealing with the water containing any appreciable quantity of suspended matter. Whenever there is a more quantity of suspended matter, you don't go for that slow sand filters. The effect of slow sand filters is to remove the turbidity by staining. We studied that mechanical staining, and to remove the bacteria by biological action. You know that biological action also. It is not particularly effective in removing of colloidal turbidity. That is very important. Slow sand filters are not very effective in removing the colloidal turbidity. Please look at this figure. This figure is figure of slow sand filter. The water is entering from this side, from sedimentation tank. There is a break pressure chamber is here. This chamber is called as a break pressure chamber. Water is entering into the slow sand filter. There is a filter bed of sand and gravel, and below that under drains are provided here, and there is a one pipe. We called it as a, this pipe is telescopic pipe. We called it as a telescopic pipe. There is a filtering head or head loss from the top of pipe to bottom part of this particular fan section area. Then there is a constant head is also there, which is shown here. This is the constant head which is shown here. This is constant head. This is the filtering head or head loss, and possible negative head is shown here from the top of sand to the bottom part of that telescopic pipe, which is top part of the telescopic pipe. And this figure is very important in the examinations, especially for descriptive type of examination. So you people must go through this figure and must remember this figure with particular different types of heads and also sand and gravel bed. Then essential features. We are going to study the essential features of slow sand filter. A slow sand filter unit consisting of following parts. First is the enclosure tank, second is the filter media, third is the base material, fourth is the under drainage system as we seen in that figure, and fifth is the appurtenances. Enclosure tank. The traditional slow sand filter is an open basin, usually rectangular in size, built below finished ground level. The watertight basin or a tank is constructed either in stone or a brick masonry with a coating of waterproof material. The floor has a bed slope of 1 in 100 to 1 in 200 towards the central drain. The surface area of tank varies between 50 meter square to 1000 meter square and is found on the basis of filtration rate, which varies between 100 to 200 liters of water per meter square. The depth of tank varies from 2.5 to 4 meter. You must know that. Filter media. The filter media consisting of a layer of sand which is 90 to 110 centimeter thick. The effective size of sand from 0.20 to 0.35 with a common value of 0.3. The coefficient of uniformity varies from 2 to 3, the common value being 2.5. The finer the sand, better will be the bacterial efficiency, but slower will be the filtration rate. That is very important. Such a type of questions are asked in an objective type of examination. The finer the sand, better will be the bacterial efficiency, but slower will be the filtration rate. Fine sand is suitable when pre-treatment is poor, high bacteria and turbidity removal efficiency is desired, and saving of wash water is not an important factor. However, if pre-treatment is good and water is to be treated, not highly polluted, coarser sand is also suitable or suitable action. Base material. The filter media is supported on a base material consisting of 30 to 75 centimeter thick gravel bed. The gravel base is laid in the layer of 15 centimeter with topmost layer of fine material and bottommost layer of coarse material. The topmost layer is of fine material. That is very important. Under drainage system. The filter media and the base material are supported over the under drainage system, which eventually collects the filtered water and deliver it to the clean water reservoir. That figure which is shown to you, shown that under drainage system consisting of central drain and which are collecting the water from number of lateral drains. There is a central drain at the bottom and which is collecting the water from the lateral drains and which are spaced at a distance of 2 to 3 meters center to center. They may be also open jointed tiles sometimes. Appurtenances. The various appurtenances that are generally installed for efficient working are the devices for measuring loss of head through the filter media, controlling the depth of water above the filter media, maintaining the constant rate of flow through the filter. Figure shows adjustable telescopic tube for maintaining constant discharge, which is already shown to you. The difference in water level between filter basin and the outlet chamber is only 10 to 15 centimeter. But as the upper portion of the filter sand gets clogged due to impurities of the water, the filter head increases. In order to maintain that constant discharge, the telescopic tube is adjusted manually in slow sand filter. So in the appurtenances, telescopic tube is very important for maintaining the head. Then efficiency of a slow sand filter. The normal rate of flow is slow and filter may be between 100 to 200 liters per hour per meter square of the filter area. You must know that rate. They are highly effective in removal of the bacterial load from the water. They are expected to remove 98 to 99% of the bacteria in the water under normal conditions. However, if operated at slower rates with some preliminary treatment and chlorine, the overall bacterial efficiency may reach to 99.5 to 99.9 and the removal of coliforms is equally high. The slow sand filters is not effective in the removal of colloidal turbidity as discussed earlier. The slow sand filters will not successfully remove turbidity over 50 ppm parts per million, that is for water parts per million and mg per liter both are the same. For water having higher turbidity, preliminary treatment for turbidity reduction is essential. The slow sand filters do not materially reduce the color of the water. In most of the cases, it removes only 20 to 25% of the color in the applied water. If the color is higher than 25 to 30 Hazen units, slow sand filters should not be used. Slow sand filters are also not effective in removing any high concentration of manganese in the solution. Then we are going to discuss the rapid sand filters and especially that is gravity type. You should study the pressure type from any textbook. The basic defect of slow sand filter is its low filtration rate due to large filter area is required. So filtration rate is less and area required is more. A rapid sand filters differ from a slow sand filter in the following aspects: effective size and uniformity coefficient of filter medium, the rate of filtration and filtration head, and method of cleaning the filter and frequency of cleaning. Usually rapid sand filtration is preceded by sedimentation with chemical coagulation. The rapid sand filters are two types. First is the gravity and second is the pressure as discussed earlier. The gravity type rapid sand filters usually filter medium which is coarser than that of used in the slow sand filters. In the pressure type of rapid filters, water is allowed to filter under pressure through a filter media. The pressure is used. The rapid sand filters of gravity type are most commonly used in water supply projects that are going to discuss right now. Please look at this figure. Figure shows the water storage, wash tank. Figure also shows the filtered water storage tank. Figure also shows the wash water troughs also. It shows the layer of sand and gravel here, especially a gravel. It shows the effluent come here and goes into that water tank, and after that water tank it is collected into water storage tanks. So water level while filtering, you must know that this is the water level while the filtering. These are the wash water troughs also shown here. Drainage system is shown here. These are the lateral pipes shown here. And such a type of rapid sand filters is used where area required is less. So you must go through this figure. The figure is plays very vital part in descriptive type of papers and also to give you an idea in objective type of papers. The essential features of rapid sand filter gravity type are the enclosure tank, filter media, base material, under drainage system and appurtenances as we discussed in slow sand filter. The enclosure tank is usually smaller in size and therefore placed under a roof. The tank is generally rectangular in plan, constructed either of masonry or concrete, coated with a waterproof material similar as that of slow sand filters. The depth of tank varies between 2.5 to 3.5. Each unit may have surface area of 20 to 50 square meter. They are arranged in a series. The length to width ratio is normally kept 1.25 to 1.35. L to B ratio is 1.25 to 1.35. In addition to under drainage system, the tanks have CI or RCC troughs spacing across the length or width of the walls for the distribution of water to be filtered during the normal operation, and for collection of wash water during cleaning operation. During normal operation, the troughs remain submerged. Filter media. The sand used for filter should be free from dirt, organic matter and other suspended matters. It should be hard and resistant, preferably of quartzite. The size of sand most suitable for particular purpose will vary considerably. The finer the suspended particles to be removed, the smaller sand size should be used in order to increase the surface area of sand grains in the sand depth of the bed. Rapid sand filters have effective size between 0.35 to 0.6 mm and the common value being 0.45 mm. The uniformity coefficient is in between 1.2 to 1.7, the common value being 1.5. The depth of sand media varies between 0.6 to 0.9 mm. Then base material. The filter sand media is supported on the base material consisting of gravel or graded gravel layers. The gravel should be free from clay, dirt, vegetable and organic matter and should be hard, durable and round. Its total depth varies from 45 to 60 centimeter and normally laid in the following layers. In order to check the gravel upset caused by the localized high velocity during the backwash, a 6 to 8 centimeter layer of garnet or ilmenite is placed at the top of gravel bed. So layer of garnet is important. The under drainage system serves the two purposes. It collects the filter water uniformly over the area of gravel bed. It provides the uniform distribution of the backwater without disturbing or upsetting the gravel bed or filter media. There are many under drainage systems such as perforated pipe system is there, pipe and strainer system is there, wheeler system is there, leopard system is there, leopard and Wagner system is there. So you must study these systems if you want to go through this chapter very elaborately. Then appurtenances. The following are the important appurtenances provided in the rapid sand filter, that is wash water troughs. Wash water troughs are provided at the top of filter to collect the backwater or backwash water after it emerges from the sand and to conduct it to wash water drain. They are CI pipe or RCC troughs spanning across the width or length of a tank. The bottom of the trough is kept above the top of the expanded sand to prevent the possibility of loss of sand during the backwashing. So you must study all these parts very carefully. Air compressors. Air compressors are used to supply the air for agitation of the sand during the washing of filter. So you must know that why air compressors are provided to supply the air for the agitation of the sand grains. Then the rate control devices. For each filter unit, the flow of effluent, the wash water supply and the wash water waste must be controlled by suitable devices, and these suitable devices are termed as a rate control devices. Performance of rapid sand filter. The turbidity. If the influent water does not have turbidity of more than 35 to 40 ppm, the filter can reduce the turbidity to less than 1 ppm. Since the coagulant and sedimentation always precede filtration, the turbidity of water applied to the filter is always less than 35 to 40 ppm. Color. The rapid sand filters are very efficient in color removal. The intensity of color can be brought down to 3 on the cobalt scale. Colorless water can be produced by rapid filtration after the addition of polyelectrolytes immediately in the advance of filtration. Iron and manganese. It is less efficient in removing the manganese, but it is very effective in removing the iron. Taste and odor. Unless special treatment such as activated carbon or pre-chlorination is provided, rapid sand filter not ordinarily remove the taste and odor. So it is not effective in removal of taste and odor. So comparison between slow sand filter and rapid sand filter. This is the very favorite question for descriptive type of examination. The rate of filtration for slow sand filter is 100 to 200 liters per hour per meter square. For rapid sand filter, that is 3000 to 6000 liter per hour per meter square. Loss of head. 15 centimeter initial to 100 centimeter final in slow sand filter, but 30 centimeter initial and 3 meter final in rapid sand filter. The size of bed required large area. For rapid sand filter, it requires small area. Coagulation is not required for slow sand filtration, but for rapid sand filtration, coagulation is required. Filter media, as we discussed, effective size is 0.2 to 0.35 mm. CU is 2 to 3. Depth of water is 105 centimeter, reduced to not less than 30 centimeter by scraping. Effective size in rapid sand filter for filter media is 0.35 to 0.6. The CU, that is coefficient, 1.2 to 1.7 for that sand, and depth is 75 centimeter, not reduced by washing. Base material for the gravel, the size is 3 to 65 mm in slow sand filter, and depth is 30 to 75 centimeter. That size is 3 to 40 centimeter in rapid sand filtration. The size get reduced for base material, and depth also increase. The depth is 60 to 90 centimeter. Under drainage system, split tile laterals discharging into the tile or concrete main drain, or perforated pipe laterals. Perforated laterals with mains or Wheeler system or Leopard system or Wagner system for under drainage for rapid sand filter. Method of cleaning is scraping of top layer to 15 to 25 mm in the slow sand filter, and agitation and backwashing with or without compressed air in rapid sand filter. The amount of wash water required is 0.2 to 0.6 of water filtered. For rapid sand filter, that water quantity wash water required is more, 2 to 4% of water filtered. Period of cleaning in slow sand filter is 1 to 2 months, but for rapid sand filter, it is the disadvantage. It requires 2 to 3 days for the cleaning. Penetration of suspended matter superficial, but in rapid sand filter it is deep. Supplementary treatment of water is chlorination in slow sand filter, and rapid sand filter it is also chlorination. Efficiency, very efficient in removal of bacterial load, that is slow sand filter, and rapid sand filter is less effective in removal of bacterial load, but it is more efficient in removal of color and turbidity. Then economy. High initial cost for the slow sand filter because area required is large, but cheap and economical are the rapid sand filters. Flexibility, not flexible in meeting variation in demand of water, that is slow sand filter, but rapid sand filters are flexible, quite flexible for reasonable fluctuation in the demand of water. Skilled supervision in slow sand filter is not essential, but for rapid sand filter it is essential. Depreciation cost is relatively low in slow sand filters but relatively high in rapid sand filters. So this is enough, I think, for filtration for diploma and degree level students, and also this lecture is useful for the Mpsc students. So thanks for calmly watching this lecture, and I am going to deliver the next lecture shortly regarding water supply engineering to